I'm going to go over free response question number 4 from the 2022 AP Calculus BC exam. And for this problem, we're told that an ice sculpture melts in such a way that it can be modeled as a cone. So I guess it's an ice cone or whatever. And the radius of the base of this cone is given by the function r. And in this table here, we have some values of r prime, the first derivative of r. And for part A, we have to calculate the second derivative of r at 8.5. And we have to show the computations. So, of course, to do that, we're just going to calculate the slope between these 2 points right here. Because 8.5 is right in the middle of 7 and 10. So let's write this down here. We're going to have r double prime of 8.5 approximately equals, and since they want us to show our computations, I think what I'm going to do is I'm going to write down r prime of 10 minus r prime of 7 over 10 minus 7. So this is how we calculate the slope between 2 points. Just think back to Algebra 1. It's the difference in the y's divided by the difference in the x's. Of course, in this case, the y's are our r prime, and the x is our t. And now let's just go ahead and plug in these values here. So r prime of 10, we get from the table right here is negative 3.8. And then we have to subtract r prime of 7, which is this one right here, negative 4.4. And we'll still divide that by 10 minus 7. And for the last thing, we have to indicate units of measure. And the top here, we have centimeters per day, and then we're dividing it by days. So that's centimeters per day per day. So I'll write it like this, centimeters per day per day. And now we'll move on to part B. So for part B, we have to determine if there exists a time t between 0 and 3 for which r prime of t equals negative 6, and we have to justify that. The answer is going to be yes, because as you can see, between 0 and 3, we do have negative 6 being in between these two values right here. But we have to be fairly detailed in our justification here. So what I'm going to do is say that because r is twice differentiable, which they told us on 0 to 12, but I'm just going to put down 0 to 3. Well, let me use the bracket notation here. 0, 3. Again, because r is differentiable on 0 to 12, it's certainly differentiable on 0 to 3. That tells me that r prime is once differentiable on this interval, 0 to 3, and therefore r prime is continuous on 0, 3, because differentiability implies continuity. And one more thing I'm going to say here is that negative 6 is in between these values. So I'm going to write this down as r prime of 0 is less than negative 6, which is less than r prime of 3. And because negative 6 is in between these two values of a function and the function is continuous, I will now say that there must exist a t on this interval from 0 to 3 such that r prime of t equals negative 6 by the intermediate value theorem. Let me move this up slightly so you can see it. By the intermediate value theorem. And I think the abbreviation is also okay on the test, but if you want to write it out just to be safe, feel free. And I think this would be a fine justification for this part. We'll move on to part C. Okay, for part C, we have to use a right Riemann sum with the 4 subintervals indicated by this table to approximate the value of this integral right here. So to do that, we're going to take the difference in these two and multiply it by this. And then we're going to take the difference in these two, multiply it with this. Then we'll take the difference in these two, multiply it with this. And then we'll take the difference in these two and multiply it with this. So let's go ahead and write that down right here. We'll say that this integral approximately equals, so we start with 12 minus 10 times negative 3.5. And then we add the next one, which I'll put in red, 10 minus 7 times negative 3.8. And then the next one is going to be 7 minus 3 times the negative 4.4. And the last one is going to be 3 minus 0 times negative 5. And that's it for this part. We'll move on to part D. So part D is a relative rate of change problem. We have to find the rate of change of the volume of the cone with respect to time at time t equals 3. And then here we have the volume formula, and here we have various values. And I want to make some sense of these values before we start the problem. So we're told that the height of the cone decreases at a rate of 2 centimeters per day. So that's going to be the dH dt. So that tells me that dH dt equals a negative 2. And all this is when t equals 3. And we have 100 centimeters is the height, so that means that h equals, oh no, I'm sorry, the radius is 100 centimeters. So r equals 100. Height is 50 centimeters, so h is 50. Come on. All right, so now we have that established, let's go ahead and take a look at this formula here. V equals 1/3 pi r squared h. Let me write it down on the side here. V equals, and I'm going to write the 1/3 pi as just pi over 3. And then we have the r squared h. Now, we're looking for the rate of change of the volume with respect to time. So we're looking for dV dt. So I'm going to go ahead and take d dt on both sides of this formula, or this equation right here. So we'll do a d dt here, and a d dt here. And now let's see what that gives us. Let me get the black pen out again. All right, so on the left side, we just have dV dt, which is what we're looking for. And this equals, so we have the pi over 3 first. That's a constant multiple, so we'll just keep that. Now let's do this carefully. We're differentiating r squared h, and r and h are both functions of t, so we have to use the product rule here. So let me open a parentheses for the result of the differentiation here. So to use the product rule, I will keep the first function, which is r squared, multiply by the derivative of the second, which is the dH dt. Then we have to add the second function, which is h, times the derivative of the first. So we have to differentiate r squared with respect to t. So first we'll do the power rule, differentiate that, we get 2r, but then we can't forget the chain rule, multiply by the derivative of the inside function. So that's going to be a dr dt. All right, so now we have our dV dt, and we just need to plug in values for all of these, and that will give us the value for the dV dt. So we'll say dV dt at time t equals 3 equals, all right, we still have the pi over 3. All right, let's see. R is 100, so we'll have the 100 squared. dH dt is -2. And then plus, we have the h, which is 50. And then we have the 2r, and again, r is 100. And then we have to multiply by dr dt. Now, you don't see dr dt over here. To get the dr dt, we have to look back to this table. Here's our r prime, also known as the dr dt. And we're interested at time t equals 3. So that's going to be a -5. So we'll multiply this by -5. And now let's see, I just want to make sure I have the correct number of closed parentheses here. This is 50 times all this guy's right here. And then I have to have a closed parentheses because I'm distributing the pi over 3 into all this. Okay, so we have solved the problem. I don't think we need to put down units because they gave it to us right here. And that's it.